Hi, hello everyone. This is Chandrasekhar P, Assistant Professor, Department of ECE, ATM College of Engineering, Mysore. Today I am going to give a session on how to write a program for stop and wait protocol and sliding window protocol using C. Before going to explain the coding of this protocol, first we'll see what is stop and wait protocol. Stop and wait protocol, also refers to as alternating the bit protocol, is a method of telecommunication to send an information between the two connected devices. It ensures that information is not lost due to dropped packets and that packets are received in the correct order. It is the simplest ARQ mechanism. A stop and wait ARQ sender sends one frame at a time. It is the special case of the general sliding window protocol with transmit and receiving window size to equal to 1 in both cases. So this is then a simple to understand. So once when the data sends from an source to the destination, the sources are called as a sender and destination is called as a receiver. The packet 0 is reached at an receiver. Receiver sends an acknowledgement of an 0 saying that the packet is reached successfully. Once again, after doing that, sender will again send a one more packet, and to that particular packets again the receiver send an acknowledgement. So acknowledgement, after receiving a valid acknowledgement, the receiver sends an acknowledgement. If the acknowledgement does not reach the sender before a certain time known as a timeout, the sender sends the same frame again. The timeout countdown is reset after each frame transmission. The above behavior is a basic example of stop and wait. However, in a real life implementation vary to address certain issues of a design. One problem is when the acknowledgement sent by the receiver is damaged or lost. In this case, the sender does not receive an acknowledgement, timeouts and sends the frame again. Now the receiver has the two copies of the same frame and doesn't know if the second one is a duplicate frame or the next frame of the sequence carrying an identical data. Another problem is when the transmission medium has such a long latencies, that is a delay, that the sender sends out run out before the frame reaches the receiver. In this case, the receiver resets the same packets and actually the receiver gets two copies of the same frame and sends an acknowledgement for each one. The sender waits for a single acknowledgement, receives two acknowledgement, which may cause problem. If it is assumed that the second acknowledgement is for the next frame is the sequence. So sliding window concept. Here the sliding window concept is having an two parts. One is a frame sent but not acknowledged, and another is a frame that can be sent but not received from any of the upper layer. The send window is an abstracted concept defining an imaginary boxes of a size 2 to the power of m minus 1 within three variables sf, sn and sz. The side window can slide one or more slot when the valid acknowledgement arrives. The receiver window is an abstract concept defining an imaginary box of size 1 with one single single variable Rn. The window slides when the correct frames has arrived. Sliding occurs one slot at a time. So algorithm. In a stop and wait protocol, first we need to generate a random timer to the data which is going to be entered, and after gives the total number of frames to be transmitted. It transmits the first frame and receives an acknowledgement for the first frame. Again, it transmits the second frame, it receives the second acknowledgement for a particular frame. And similarly, it goes, if we going to send n number of n frames, for an n number of frames, n times the acknowledgement will be received. Next, finding the remaining frames to be sent. If an acknowledgement is not received for a particular frame, retransmit the frame alone again. Repeat these steps 5 to 7 till the number of remaining frames to be sent becomes 0. Next, sliding window. So again, in a sliding window, the window size is very much important. It reads the number of frames to be transmitted, randomly selects the frames to transmit, transfers the packets until it reaches the maximum defined size, resume the window size and repeat the above two steps until the packets get over. So this is then a program of an stop and wait protocol. So stdio standard input and output header file, which includes then printf and scan functions. Frame size is taken as an integer, sent is taken as an integer, and acknowledgement is taken as an integer. First enter the frame size. Those frame sizes will be stored in an variable called integer called frame size. And check for a condition. Here we are going to use an while condition. So in a while condition, with this while condition will be always, it will be a true condition itself. So to enter the frame size, once the frame has been entered, the frame has been transmitted. That is, if I am going to send a 0 frame, the 0 frame has to get transmitted. If I am going to send an 1 frame, the 1 frame has to get transmitted. Like this, for n number of frames to be sent, the n number of frame is size which is going to be assigned. If the sent frame and the frame size are equal, then the loop gets stopped. If not, again it will ask to enter which acknowledgement you need to receive. So again, if an acknowledgement is greater than the frame size, whatever we have been specified, again the loops gets break and sends an acknowledgement and works like an stop and wait. Next is a sliding window. So again, in a sliding window, we need to enter the number of n frames to transmitted, which will be stored in the variable called f, and enter the how many number of frames that has been transmitted. So once the frame is get transmitted, we use here is a percentage which acts like an random, that is to calculate the coefficient of it. So I percentage w is equal to 0 means I is an integer. If an 1 is percentage modulus of w means if it is in 0, then the frame size will be entered. If not, it will acknowledgement for the above frames sent by is received by the sender. Else, another condition to print the same above is that f percentage w is not allowed. F percentage w is not allowed, is that if it is not equals to 0, the acknowledgement for the above frame sent is received by the sender. So this is the output of a stop and wait protocol, where I am going to transmit 8 frames of data from the source to the destination. So sending in frames is the first frame. For that first frame, I am going to get an acknowledgement as an 1, and similarly, like till the 7th frame, I am going to get an acknowledgement. And at the 8th frame, it waits for 1 second, and again sending in frame of 7 and acknowledging for 7. Once I get an acknowledgement here, it is waiting for the seconds to be get complete off, that is it gets to be finish off, and wait for a period, and again the retransmission of the frame is going to be occurred. Again, if the retransmission is done, the acknowledgement is going to be obtained, and again the next bit is going to be carried out. In a similar manner, for a sliding window also, enter the window size, that is an 4, and it asks for the frames to be transmitted, how many number of frames to be transmitted, that is I am going to take an example of an 6. Now I am going to enter which are those 6 variable from 1 to 7. So each number represents a frame count. With the sliding window protocol, the frames will be sent in the following manner with no corruptions of an data. I am not going to check any CRC here. After sending in frame at the each stage, sender waits for an acknowledgement to be received for the next 2 frames to be transmitted. Once 1, 2, 3, 4 are received at the same time, then the sender will send the acknowledgement to the receiver will send an acknowledgement to the sender by asking n 5 and 6 acknowledgement for the above frame size is received by the sender. So this is then a concept of a stop and wait protocol and a sliding window protocol. So for more details, please refer to the Farazan textbook, Computer Networks, Communication Network, Farazan textbooks. And if you like these videos, please do like it and comment on the videos. Also get subscribed to the our channel Atmiya Electrocrats. Thank you. Hi. With a continuation of an stop and wait and a sliding window protocol, in connection to that, I'm going to show the demo for this. So first thing, I need to create a two files of a name called stop and wait.c and another file which is called as a sliding window. So these files has to be executed. So I have already gotten a program of a sliding window and an stop and wait. So I will copy those program. I will copy those program and will run execute. Once the compilation is compiling is done, we are going to run the output file which is stored in an output, which stores in an output. This is the program of an stop and wait. I'm just copying it and pasting in my file stop and wait. So it's already opened. So just I need to paste it and will save the file. So once the file has been saved, I need to execute it. So I will open the terminal for that and will navigate into a desktop. Right now I am in a virtual box, so it will get navigated into a desktop. CD space desktop. So right now I am in a desktop folder. So in the desktop folder I have got a file called stop and wait.c. So I am going to compile by using a command called gcc space stop and wait, that is the file name. So once it has got compiled, so you are going to obtain a output file with a name called a.out. So that is the executable file. I need to run those executable file. So to run executable file, I have got a command called ./a.out. So this will result the output of that. So here I am going to specify what is the entering the number of frames that is going to be transmitted. So the number of frames I am going to give as an 8. So these are the number of frames that has been transmitted. So please enter the last acknowledged received. So last is what? A 7 has been received. So I will present 7. So 7 frame has been transmitted. Similarly, please enter. If I give 9, what will happen? So because the maximum number of the frame what I have been entered is an 8. If I give 9, so that is not the number of frame, that is out of the number of frames what I have been entered. So it's get automatically gets the operation gets aborted. That means it's get discarded. So let us have one more example. So if I say the number of frames is an 10, and if I say the frame is an so I have transmitted a 10 frames from a 0 to 9 and I am asking to enter. So while acknowledging that, if I going to press 2, so it says that the 2 has been already transmitted till a 9. So it understood that 0 and 1 is already transmitted. So if the value is above 9, so if the value is above 9, if I suppose I need to get an acknowledgement for an 12 which is an out of the frame size what have been entered, so it gets the automatically the operation gets aborted. That means it has to execute, it is to exist from the program. So this is the features where the stop and wait protocol is going to be work. And next comes with a sliding window concept. So for a sliding window concept, I have gotten a program of a sliding window. Just I will copy down the programs. and we'll go to my document. So already have been created a file. I will open those file, that is an already which has been created called as an sliding.c, and I will paste that and will save my stuff. So once it has been saved, next I need to compile these steps. So I'm going to write I need to compile the program. So to compile a program, I have got a command called gcc sliding dot sliding gcc sliding dot c. So there is a known error. Next I am going to run this as an ./a .out, and we are asking what is the size of an window. I am going to just given the 3 is my size of an window. Next it is asking how many number of frames that has to be transmitted. It is in 5 number of frames that has to be transmitted. So it is asking which are those 5. I will start from an 1 2 3 4 5. So these are my 5 frames. So while transmitting these 5 frames, the frames will be sent to the following manner with no corruption, that is with an error free. After sending in 3 frames at every side, it waits for an acknowledgement to be received from the receiver, and acknowledged for the above frames is received by the sender will be an F4 and 5. If I say the window size is 5, and if I give the size of the window, the output will be obtained for the 5 itself. So I am going to give an 5, and I am asked to give an a 6 frames to be get transmitted. That means window size is 5, the frame system will transmitted is 6. Therefore the frame which are those 6 frames, that is 1 2 3 4 5 and 6. So these are the frames, and at the last the size of the window is 5, so it has been covered till the size of the 1 to 5, and it will acknowledge for the last bit of an data. So thank you for watching this video, stop and wait protocol. So this is the simplest video which have been executed by us, and thank you for my instructor Abhinandan for supporting to do that, and also I will thanks my colleague Mrs. Darshini MB for creating such a beautiful manual. Thank you.